One of the things that we've really invested a lot in since kind of day zero of Poolside for the last 2.5 years has been in reinforcement learning. This was our big view on the world when the world did not share that view at mass, right? That reinforcement learning was going to become the most important scaling axis. And while we apply RL today across so many different areas and domains and things, probably the OG RL of Poolside has really been around code execution and code execution feedback. Originally, just patches, exploration, running tests. Today, far more complex with large-scale agents runs. But code execution relies on this pretty impressive environment. Can you talk us through a little bit? What is it? And then maybe we can go into how it's built.
Yeah, so I think it's kind of like you said, right? We were doing reinforcement learning before reinforcement learning was cool. And for us, that has always been around coding.
I think reinforcement learning has been cool always, by the way.
Well, maybe not popular, but always.
Exactly, for LLMs, yeah.
But I think it's, in particular, we wanted to train models that are good for programming and good for coding.
Yeah.
And if you think about the way that humans learn, it would be preposterous for us to learn how to code by reading every single C++ book in existence, right? It would be nonsense. No one would ever write anything. The way that people learn to write code is by writing code and seeing where it goes wrong. It's writing tests, it's learning the edge cases, it's doing sort of the very rote manual work to actually build up expertise.
Yeah. And increasingly harder tasks as you learn more.
Exactly. And if that works so well for humans, why would it not work well for AI? And that's kind of what our code execution environment does. So we provide a playground for our models to learn to write code, to execute code, to see the feedback, to see compiler errors, linting errors, all of these things that as humans we know help us to learn. We expose that to the model. And so just to give you an example, so what we do is, let's say there's some repository in the world. And by the way, we have nearly 800,000 of them. So one is perhaps not a representative sample, but we'll take it. We take this repository and we produce a container, so a Docker image or an OCI image for this particular repository and all of its revisions. And then we just deploy this onto some nodes. Just does a lot of heavy lifting, but we deploy it onto some nodes. And then we prompt the model with some workflow like, hey, implement this test, do this thing, much like you would with a human engineer.
Yeah, and increasingly larger and more abstracted tasks, right? It started with like write a function, write a test, and these days it's pretty large-scale tasks that we're throwing at.
Especially with agents, we've definitely grown the scope of the things that we do. It's one of the good things that, again, the model factory enables this, right? Because we have agentic models now and they can do all of this stuff and they understand what it means to have a long-running task. But in any case, we just let the model play and explore in one of these environments. Having revisions in particular is incredibly useful because every revision of a repository, in a sense, represents a resolved task by a human. So you can see a commit that is, implement this test. Well, that serves as a really good task for a model, especially over longer spans, like you were saying. If you go from just treating commit by commit, that's one thing. But if you look at like epics of, right, we went from version 2 to version 2.2 and we implemented all of these things and model, please do the same thing. That is essentially indistinguishable from a good software engineer at that point, especially on high quality repositories, right? It's not just some JavaScript project or something like that, right? It's a really big, large scale project.
I think you mean small demo JavaScript project, not to piss off anyone who's listening to.
Not to disparage the wider world.
Disparage any of the wider world.
But having a reasonably sized, high quality repository that a model can learn on and learn to implement those things, basically indistinguishable from a real software engineer. And that's where we want to get to. We want to get to where a model can do the same tasks that a regular engineer would do because it's so useful for the world. It's so useful for engineers. I mean, I use our model all the time for exactly these reasons, right? It helps me to be faster at what I do. And I'm not just saying that as someone who works here. It's actually a useful thing to have. And having a model that understands, especially like long-running tasks end to end, is such a game changer when you're doing development.
You mentioned 800,000 repositories, which to me is all still pretty wild because our journey on that was, you start with building some Docker images from repositories that have clean Docker files.
Yes.
And you get to the hundreds, maybe thousands, and then you realize that, well, if you want to get much larger, you have to build something far more complex, right? Because the world it's not every repo is just buildable. And so we've gone through this massive system that we've built to do this. It's automatically ingesting repositories on one end from the web. It is filtering them. It is checking for licenses that we need to exclude. It's doing all this work, taking quality heuristics. Then it goes in, and these days it's no longer even just that we're doing it rule-based or heuristic-based. We're starting to use our own agent that was trained in an environment to actually build the next environments in which it's going to train. And the reason this number is so big is that we hold the point of view that if you're really looking to push capabilities of models in these longer running tasks, like multi-step complex reasoning and actions, is you want a very large amount of diversity.
Yeah. So going back to the building point, I think we all had this very gut feeling of that what we were doing was wrong. And I don't mean wrong in a correctness sense, but I mean, when you think about how a human will build a repository, what are they going to do? They're going to go to the project, they're going to look at the README, they're going to follow the steps.
Yeah.
And I think we all found it quite infuriating that we couldn't mimic the same thing with the system that we had before.
Yeah.
Because that's obviously the right solution.
Yeah.
And so building agents that can actually look at a README and go, oh, I need to follow these steps and debug it when it goes wrong is it just feels like the right way for things to be.
I think this is a little bit part of our philosophy, right? We've taken a very anthropomorphized view of intelligence. We look at how do we do things as a software developer, how do we do things as a human, and we almost always try to first get our models to do it that way. Doesn't mean models won't be able to do it far more efficient or in different ways, but it's been a really good starting point for us. And it is a very nice moment where you're now, the thing you created is helping to create the thing that is improving itself.
Yeah, it's amazing. The Model Factory has this tendency or this quality to it, where when you build good pieces, they enable further improvements to themselves, right? You can take the bits that you have and then almost like, I liken it to rock climbing, right? You build something to get you to one place and then you can use where you are to get to another place. And over time, you just climb towards something that's way better than what you had before.
Well, that brings a little bit to the one kind of metric I kind of look at, probably best abstracted by saying is the gradient of our progress getting steeper and steeper. And that's kind of the nice thing in the last time we've been here together since day zero. It just feels every single month we're moving faster and faster. And there's of course the metrics we can see that in terms of number of experiments and results and things that we get, just going up and to the right, increasingly at a faster pace. But it's also kind of the feeling, which I think is what gets us all so excited, is because when we started, there was nothing and we had to play catch up. And now we're at a place where catch up is starting to look more and more in our rear view. So that feeling is pretty exciting.
I think to put it in a slightly different way from an engineering perspective, the thing that excites me the most is that things that used to bother us don't bother us anymore. So you talked about building containers earlier.
Yeah.
That was a real pain to get right. That took us quite a while to get to a position where we were happy with it.
Yeah.
And now we just don't even talk about it. It's not something that when we hire someone new, we just say, of course, you can go and improve this and learn about this if you want, but you don't need to think about it because you know that it works.
That's actually the very funny thing in the interview processes, because someone will come and ask you these questions, and they're obviously coming from a place of something that was really painful for them before. And to us, they're no longer a discussion topic because it's kind of, hey, it's solved. Doesn't mean we don't have a lot of other things to fix, and there's other things that are still painful. But it's a very good measure of progress, kind of seeing that go step by step and become non-topics.
Exactly, and it means that you can build things very easily on top of that. So, for example, now that we have code execution that works, you can mix that into so many different places. RL, synthetic data generation. There are so many examples of where you can plug good code execution in. That means that you can just generate so many behaviors. It's really the only way that we can scale our experiments. You have linearly many pieces, but if you combine them cleverly, you get super exponentially many behaviors. And that's really what you want.
Scaling via engineering, not scaling by people.
If we come back to the 800,000 repositories, can you imagine how many people we would have needed to have hired to have built that, right? It would take so many people so long. And I don't think anyone joins Poolside because they want to do boring work. I think there are probably some people that would enjoy that task, but not the sort of people that we hire, right? We want to solve hard, new, pressing problems. Building repositories is not one of those problems. So we're able to keep our team much smaller because we don't have to worry about things like this. We scale with engineering, not with people. Although, of course, the team keeps growing and we keep hiring many amazing people, but it's just one of our scaling axes.
Yeah. What are you most excited about?
In code execution or in the Model Factory?
Just in general in the Model Factory. And
the thing that I love about the Model Factory is that it gives you a very clear path of how to improve things, right? So with code execution, it's a good example. We know at the moment where the rough edges are because they're logical conclusions of where the rough edges are in other places, right? The agent is a good example, right? We saw that we weren't building enough repositories successfully, these static rules. And so we took something else from the model factory and then built that to improve our code execution. Now our code execution is better. We can use that to bootstrap other things. It's really, this self-feeding nature is really, for me, the main selling point. If we didn't have this, I don't know where we would be.
Yeah, it's what's given us this speed. The model factory sets us up really well for agents doing research. Right? Because now we've got this very well-defined mono repo. It's got all of these assets and components. Evaluation is automatically built in, the system itself. So I think we now have on the horizon agents that are actually doing their own research in the model factory and improving it. The first step towards seeing like a self-improvement loop for models that goes even beyond the ones that like we instigate ourselves.
Yeah, I agree.